This is Mr. Anderson for Kellogg Community College. Sorry about breaking this up into two sections here, but I had decided to change the problems as I was working through them on the microphone here. I had noticed I didn't really quite get the answer I wanted to, so I've changed the worksheet, so please do that or use the ones that are updated on the Moodle page. So what I have here is an equation which is x to the fourth power minus 3x squared minus 4. And we're going to find when this hits the ground, and this is going to be kind of a weird graph because it can have up to 4 answers, and on this one it looks like it only has 2 answers. And let's go and figure this out by hand on how this works. So with that in mind, let's take a look at x to the fourth minus 3x squared minus 4. So this is one of these kind of simple problems, even though you have an x to the fourth in an x squared here, which means that these have to be x squareds to make our first cable of x to the fourth. But this is an easy problem because you're having to see what kind of factors of negative 4 make a negative 3. And in that case, it's x minus 4 and x plus 1, and that's equal to 0. Now, this can be factored further, so this is x plus 2 and x minus 2. And this can be factored only once. Actually, it can't be. This is as far as it can go. I maybe misspoke there, but this problem is not a difference of squares. It's the actual addition of squares, which is not further factorable. And I'll show that to you by now setting each of these equal to 0 and solving for x. So if I subtract 2 from this side, this gives me negative 2, so there's one of my answers here. If I add 2 to this side, this gives me a positive 2, which gives me an answer here. But check this out. If I subtract 1, I now have x squared equals negative 1. Try to take the square root of this. You get the square root of negative 1, which is an imaginary number. So this doesn't give me real roots over here, and you can kind of see the weird curve of the graph is not going to cross the x-axis because this is an imaginary number. So there's really only 2 solutions here and here. Now let's look at problem 10. If I look at problem 10 and type this equation in, negative x, make sure you use the negative key there, x cubed, minus x squared plus 12x. And let's look at the graph. Looks like it crosses at 3 places. Now what this means is I go here, I will see that this has a factor, a common factor I can remove. And as one of Anderson's tips is to try to remove a negative common factor if the first term is negative, because what this will do is this will give us an x squared plus an x plus 12 equals 0. So now we just have to figure out what 2 numbers multiply to make 12 and add to make a positive 1. Now, actually, when I remove the negative, I should note that this should be a negative 12 there, because that will turn this into positive, and this negative. So out of all the possibilities of negative 12, the one that would make a positive 1 is not negative 1 and 12. It's not negative 2 and 6. It's negative 3 and 4. So this is going to be my x minus 3 and x plus 4. Notice my negative x still stays there, equal to 0. And now I can set all 3 of these equal to 0. Negative x equals 0, x minus 3 equals 0, and x plus 4 equals 0. Moving the 3 over, x equals 3, which is right here. X equals negative 4, which is right here. And this one over here, if I divide both sides by negative 1, x is equal to 0, which is right here. And those are all of my solutions. Thanks for watching.